Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London. And I was supposed to be in Kiev doing this talk live. Unfortunately, as you all know, we cannot travel nowadays. So we had to do a video talk. But hopefully, in a future edition of the conference, I will be able to join you and do another talk live in Kiev because I love visiting Kiev. So today I'm going to be talking about an app modernization story with Cloud Run. This is an application that me and one of my friends we wrote a while back, and then we modernized it over the years. So what I want to do is that I want to go through that story about the initial app, and then go through the stages where we kind of modernize it along the way, and then talk about the decisions that we made and the lessons that we learned along the way. So it's a very much experience-driven talk. But I will also introduce some new technologies like Cloud Run along the way, and I want to show you some demos of that as well. I already talked about this app modernization story in my blog post. So if you go to my webpage and then look for app-modernization tag, you can read 4 blog posts on this same topic. And also the app itself, the backend of the app, it's already on GitHub, and I will show you that the link of that as we go along in the talk. All right, so let's get started. First of all, let me describe to you what this app is all about. So this was probably late 2015, early 2016. Myself and one of my friends, we were working in the same company. And we wanted to work on a hobby project on the weekends because, as you might know, when you work for a big tech company, there's a lot of legacy and there's a lot of things that you cannot control. So you usually get to use the tools that are given to you, and then you use the language that's been used. So you don't always use the latest and the greatest technology. And then all the legacy can really weigh you down, and you feel like you're not productive anymore as a developer because of all the things that you have to deal with within the environment. So in that period, we were feeling that way with my friend, and we said, why don't we just work on a hobby project where we start from scratch, build something small, build something quick over the weekend or maybe 2 weekends, and see what we can do, just to energize ourselves. And I'm originally from Cyprus, and so is my friend, and we read a lot of news from home. And then the news from back in Cyprus, they're all over the place. So there's no one single place that you can go and read all the news. So what we wanted to build is basically a news aggregator for newspapers from Cyprus. So the idea is that we would have this mobile application, and then in this mobile application, we'll have a really simple timeline where we show the news and their sources in a nice, clean UI. That way we don't have to go all these sources ourselves, and we can just open one app and get all the news from different sources. So our idea was to read from multiple sources and then kind of pick the best news according to some metric and then display them in a nice timeline on a mobile app. So when you think about it, it wasn't too difficult of a project. But at the same time, it's not too easy either because you have to read from multiple sources, you have to aggregate them, you have to display them. So it's not trivial either. So it was a good challenge, but it wasn't too challenging to make it really a full-time job. So we started with this in late 2015 and early 2016. And our initial goal in stage 0 was to get something up and running as quickly as possible. We were prototyping, we just wanted to make sure that things work and just get something up and running. I worked on the server side, and my friend who is a mobile developer, he worked on the client side of this. And initially, this is what we had. So we have the news sources that have their RSS feeds, and then we have clients that we want to get these RSS feeds to in a nice UI. And then in the middle, we created this ASP.NET application. So the server side was ASP.NET. I think the version was 4.6. It was running on Windows, and then we hosted on an IIS hosting. We were at the time I wasn't familiar with the cloud, so it wasn't on cloud. I just picked the first IIS host that I found that was cheap enough, and then just deployed the app there. So that was the server side. And the client side was built with Ionic framework. for those of you who don't know Ionic, it's how do I describe it? It's a JavaScript framework where you can write your app in JavaScript, and then you can deploy it into multiple places like Android and iOS. And we chose that because we didn't want to write every 2 separate apps for Android and iOS, and Ionic just worked for us at the time. So this was our initial app, and the app itself, I will mostly be talking about the service side of it because that's where most of the modernization happened. And the service side was an ASP.NET app, but it was actually 3 separate things. It was a reader, a transformer, and a web API. The reader, what it would do is it was an ASP.NET service that will go on a schedule to the feeds that we define and get the feeds and then bring them back to the application. So we just read the RSS feeds. Then there was a transformer that would take these feeds and it will kind of extract the things that we need from these feeds, because these feeds, they're all different kinds of feeds with different fields and they weren't uniform at all. So we had to come up with a list of things that we cared about these feeds and then find a common format for them. So that's what transformer did. It will read the feeds and it will kind of transform them into a common format that we cared about. And then I also exposed a web API for clients to call. So the clients will call this web API, the Ionic framework, and it will get the feed in this common format and it will display them, right? So it was quite simple. It worked. And we got things up and running, I think, over the 2 weekends or something like that. So we were quite happy that we could get something up and running quite easily. So the pros and cons of this initial stage was, first of all, things worked, which is always great. When you're prototyping, you want to get to the initial app as soon as possible, just to make sure that your idea is working and just prove your idea. So it was good that it was working. It was really easy to understand, right? It was a single service ASP.NET app running on a single machine, and it's being hosted on in an IaaS host. So there was not much complexity to it. It was very easy to deploy. We didn't even set up a CI/CD pipeline. All we did was basically right-click from Visual Studio, just deploy and enter the IaaS information, and there you go. You had the app up and running. And it was quite inexpensive. The IaaS hosting at the time, I don't remember the exact price, but it was a few dollars per month, basically. So it wasn't something that I had to think about too much, right? On the other hand, pretty early on, there were some negative things about this approach. First, there was too much coupling. Like, as I mentioned, our application was basically 3 separate services. It was reader, it was transformer, and it was a web API, and we were all putting them into this single ASP.NET app. We knew that we shouldn't really put all of them together, but it was the simplest thing to do, and that's what we did. But it was too much coupling right from the beginning. Secondly, the IaaS hosting developer experience wasn't good at all. For example, if you wanted to see the logs of your application, you had to FTP into the IaaS host and just download the logs and look at them. There was no alerting, or there was no metrics, or there was no way to know what's happening. Sometimes the host would go down and we wouldn't even know why it went down. So the developer experience was pretty bad with IaaS hosting, but it was expected because it was kind of cheap. We had 0 redundancy, so it was a single machine somewhere that we didn't even know. We were probably sharing the same machine with other applications as well, so there was no redundancy whatsoever. If the machine went down, our application went down. There was no persistence. Everything was in memory, right? We read things in memory, we transformed them, and we stored them from memory. We did that because it was easy to do. And our idea was to add persistence later, but at this stage, there was no persistence. And lastly, there's no resilience. Basically, if any part of the application crashed, it will bring down everything, right? So if there is something wrong with the reader and it goes out of memory, it would bring down the web API and vice versa. So we didn't have any kind of resilience whatsoever. But the good news is that things worked, and that's what we wanted to do in this initial stage. Now, The lessons learned in this stage was that, first of all, you really want to stick to your MVP, most viable product, right from the beginning. For example, in this stage or application, we were thinking of displaying news and also displaying the columns, like the authors um, from these newspapers as well. We didn't have the UI for it, but I designed the backend for it as well. So we were reading the news feeds, but we were also reading the columns feeds as well. And because I was reading two separate things, I tried to make things generic enough so that these columns read the column reader and the news reader, they could share a common base class and things like that. In the end, we didn't implement the column reading, right? And we realized that way later that we don't need it because most of the time people just read the news. But because I didn't stick with the MVP or reading the news, I basically complicated things a lot. And then later I had to remove a lot of things from our code base because we didn't need the columns, right? So you really want to define what your MVP is, and you want to stick with that even at this early stage because you don't want to complicate things, and because these complications, they carry over and they will make things much more complicated as you go forward. Secondly, you really want to research your options right from the beginning. This is for the IIS host that we chose. I mean, I chose IIS host because it was probably the cheapest option, and it was one of the first ones that just worked, and I just stuck with it. But at the end of the day, it wasn't a good choice. It wasn't reliable. There was no developer experience. There were so many bad things about it. The only good thing was that it was cheap, but that really didn't serve us well going forward. So you really want to research your options from the beginning and start with something that kind of makes sense and that will carry you forward, and you don't waste time on trying multiple platforms as you go along. You really want to avoid coupling at all costs. As I mentioned, our web API, our transformer, and our reader, they were all coupled together. And initially, we didn't think that was a big deal. But that turned out to be a really big deal later, because when the code base got bigger and bigger and bigger, then we had to decouple them. And decoupling things afterwards is very difficult. So you want to think about these things from the beginning, and you want to make sure that you're not coupling things together that are not meant to be coupled. Now, by this, I don't mean that you should create separate services for everything. No. You can still keep everything together. You can still keep them in a single service, but you can structure the code in a way that can be decoupled. So you can have separate packages or separate parts of the code where you don't really kind of put everything together. So you should think about these things from the beginning. And last point is that you need to design with feature in mind. For example, we said, okay, for the first release, we want to use in-memory persistence. So we didn't want persistence, we just want everything in memory. But we didn't make it pluggable, right? So we basically just assumed that we'll have memory and use memory. But then when it was time to introduce persistence, we had to rewrite things. We had to introduce adapters, and then we would make an in-memory adapter, and then we will make a Firestore adapter later. So we had to make things pluggable because we didn't design for the feature. We knew that we needed persistence at some point. So we should have done some kind of adapter kind of design right from the beginning. So these are some of the lessons that we learned in this initial phase. In the next phase, and this happened later in the year, so we deployed the app, the first version, beginning of 2016, and towards the end of 2016, we decided to revisit the application. We didn't do it before because we were really busy with our day jobs, but at some point we said to ourselves, oh, okay, let's just try to improve the resiliency and redundancy of the application, because more and more people started using the application, and then sometimes when you open the app on your phone, it would just spin, and something is broken in the backend or something is broken in the front end maybe, and we just didn't know why. So we wanted to improve the resilience and redundancy of our application. So for that, what we ended up doing is that, okay, we said, okay, let's just try to move off from the IIS host first, right? Because the IIS host that we were using, it wasn't reliable. And at the time, I started working at Google and I started learning about Google Cloud. So I said, okay, let's just try to move this app to the cloud and see what it takes to move it to the cloud. And what we ended up doing is that there's these things called Compute Engine on Google Cloud, which is basically a virtual machine that you can get. And these virtual machines, they can be Windows or Linux. So I deployed the app to a Windows Server VM on Compute Engine. And then once you deploy your app there, you can create what's called instance templates. So you deploy your application on a Compute Engine instance and you configure it the way you want. And then from there, you create a template out of it. And then from the template, you can create what's called instance groups. These instance groups are basically multiple copies of the same app on multiple instances of Compute Engine. And then you can hook that instance group to a load balancer. So this way, you can have an easy way of replicating your app to multiple VMs and then having them load balance behind a load balancer. In our case, we didn't need much redundancy because this was a simple app. So what I did is I still created the instance template and I still created an instance group, but we only had 2 Compute Engine instances, and then we had a cloud load balancer in front of it. So with this, we started having some redundancy because we have 2 instances, and if one of them goes down, the other one is still up. And then Compute Engine also has a lot of resiliency features that helped us as well. So in this phase, the pros and cons were, first of all, it was very easy to move from IaaS host to the cloud, much easier than I thought, because in Google Cloud, there's a marketplace with different kinds of solutions that you can install on VMs. And one of those solutions is called ASP.NET Framework template. And what this does is that basically with a single click, you can get a virtual machine with ASP.NET Framework already installed on a Windows server and with some SQL Server, local SQL Server and things like that. So basically it gives you an ASP.NET development environment with a single click. So I used that to get started, and then after that I modified things to make things work. But it was really easy to do that. Secondly, as I mentioned, with instance groups and instance templates, we get redundancy and load balancing pretty easily, and it was quite easy to work with. So everything kind of makes sense. We also got the possibility of auto scaling, right? Because what you can do with instance groups is that you can say, okay, this is my instance group, and I want to set auto scaling on it using this metric. We didn't do that because we didn't really need auto scaling, but it was good to know that in case we wanted to set auto scaling, it was available to us for free. Basically, we didn't have to do anything. It was just a configuration in an instance group. And the developer experience with Google Cloud was much better than our IaaS host. We got our logs sent to Stackdriver. We could take a snapshot of our VM and then use it as a backup in case something went wrong. We could do health checks with Compute Engine. So there's a lot of things there that made development really easy and gave us like all these like free features that we didn't really need, but it was good for the future. Now, the only downside of this move was that cloud is definitely more expensive than IaaS hosting, right? We were only paying a few dollars for the IaaS hosting, but now with Google Cloud, with 2 VMs and a load balancer, it was still quite inexpensive. And Google Cloud has a free tier that you can use that makes things quite affordable, but it was still more expensive than IaaS hosting, and it was fine for us because we were prepared to pay for the things that we got from Google Cloud. All right, so this, and then the lessons learned in this phase was that again, moving to the cloud was not as difficult as we thought it would be, and then we also realized that cloud is not just another hosting provider, right? It's not another place where you just deploy your app and forget about it. It gives you much more than that. It gives you tools, it gives you developer experience, it gives you snapshots and many, many other things. So it's basically a new development environment. And we realized that once we started working in the cloud. All right, so this app served us well for another 2 years. So from beginning of 2017, until 2019, we didn't touch the application at all. And the reason for this was that, again, we were busy with our day jobs. And secondly, there was no reason. I mean, there was no reason to touch something that's running. If something is running, why touch it? But at the same time, a few things were happening between 2017 and 2019. Number one, there was a new version of .NET called .NET Core that's coming along. And .NET Core, it's the new version of .NET that works on multiple platforms. So it's not just Windows, it works on Linux and Mac as well. So that was kind of interesting, but we were just kind of waiting to see what's going to happen with .NET Core, because initially we weren't sure whether it was something that will take off or not, but it did take off, and now it's the default .NET framework that's been used. Secondly, there was a lot of hype around containers. So everyone was taking their applications from virtual machines and they were containerizing them into Docker, and they were running them on places like Kubernetes, and there was a lot of hype about that. And people were saying how these containers are much more efficient than VMs and all that kind of stuff. And then third thing is that we didn't really like the fact that we were depending on Windows, right? There was no reason for our application to be on Windows. And because of our Windows dependency, we had to be on Windows servers, and that really limited our options. So we were thinking at some point that we want to break this dependency if we can. And last but not least is that the cost of our application, even though it wasn't that much, it was still a lot for a small hobby application. Ideally we wanted this app to be free because it's a hobby application, but with 2 Windows VMs and load balancers and things like that, it wasn't free. So we were looking for ways to make it free, basically. So because of all these forces coming into our way at the beginning of 2019, we started looking into .NET Core, and we started looking into containers, and we started to see if we can actually change our application to take advantage of all these technologies. So in this stage 2 of our application, this happened in early 2019, our main goal was to remove Windows dependency and also the cost that comes with Windows dependency. So for that, we started using App Engine. But before App Engine, first what we had to do was we had to rewrite our application from ASP.NET Framework, which only works on Windows, to ASP.NET Core Framework, which works on Windows, Linux, and Mac. So in our initial rewrite, we rewrote in ASP.NET Core 2.2, which is one of the later versions of ASP.NET. Right now, I think the latest version is 3.1 or something like that. So we rewrote that in ASP.NET Core. And I should mention that this took us only 1 day. And I was really surprised about that. I was always scared that, once I started writing on my application, maybe some package that we use wouldn't be supported, or maybe the code wouldn't be supported in some way in ASP.NET Core. But actually, Microsoft did a really good job here, and everything that we were using, they were ported on ASP.NET Core, and all the packages that we were using, they had ASP.NET Core versions. So it took us basically 1 morning of porting the code and another afternoon to test things out and make sure that it works. So within a day, we could rewrite our application in ASP.NET Core. Then we containerized using Docker, and that was quite straightforward because there's a lot of examples of how to containerize the application. And then at that point, we had the app ready for Linux. Because the app was rewritten in ASP.NET Core, it was containerized, so we could run it anywhere that runs Linux. And we were looking into deploying it into Kubernetes or App Engine. App Engine is Google's way of running Linux containers. And we were kind of split between the two. We could go with Kubernetes because that's what most people use. But at the same time, Kubernetes has a lot of moving parts, and there's a lot of complexity with Kubernetes. And we really didn't need it. All we needed was basically, here's a container, just run this container for me. And App Engine was good for that. So that's why even though we knew about Kubernetes, even though we could do it in Kubernetes, we went with App Engine Flex because it was much easier to deal with. And that's where we deployed our application. And the pros and cons of this is that, first of all, by doing this, we got rid of Windows dependency, so that opened our application to multiple places. and we got rid of Windows licensing as well. So this made our application cheaper to run. So instead of running on Windows VMs, now in App Engine Flex, we are still running on VMs, but these VMs are managed by App Engine, and they are Linux-based VMs. So we are not dealing with Windows anymore. Now with App Engine, we got free auto-scaling. So when you deploy an application to App Engine, you got auto-scaling by default, so you don't have to configure it or do anything special with it. So that was nice, that in case our application became really, really popular, we knew that App Engine could handle it. And then with App Engine, we also got some free features like revision management. So every time you deploy your application, you get a new revision. And then once you have multiple revisions of your application, you can also do traffic splitting as well. So you can say this revision gets 50% of the traffic, and then this revision gets the other 50%. So it's 50%. So you can do things like A/B testing, or just trying features in production, stuff like that. So it was a pretty good move for us. But on the other hand, we were still running on VMs. So App Engine, the version that we deployed to the App Engine Flex, it's still VM based, meaning you still have machines behind the scenes. And because it's VM based, you still get charged for those VMs. So the pricing is still VM pricing, which means that your application, even if no one is using your application, you're still paying for those VMs per second. So you're still paying for all of them per second. So even though it was cheaper than running on Windows, we were still paying for those VMs for the whole time. And last thing is that in App Engine Flex, the deployments in App Engine Flex, for some reason, they're quite slow. It can take anywhere from 5 minutes to 10 minutes, even for Hello World applications. And it wasn't a big issue for us, but at the same time, when you're testing things out, it can get annoying after a certain time. And actually, let me show you this quickly. I have a really dummy App Engine application here in Google Cloud. And then I just want to show you quickly like how App Engine looks like. So if you go to App Engine, there's a dashboard. And then if you look at services, you can have multiple services here. So these are kind of like microservices on your App Engine application. In this case, I have a default service. And then if we click on the default service, you can see that it's an ASP.NET Hello World application. If you look at the versions of your app, you can see that I have V1 and V2 on my application, and V2 is the one getting all the traffic. But then I can split the traffic here and then adjust the traffic between version 1 and version 2. You can see that there's 2 instances. So by default, everything runs on 2 virtual machines. But you can change this, and things are auto-scaled. So if I look at instances, you can actually see that these are VM instances that you can SSH into. So they're Linux machines. So this is what you get with App Engine when you deploy your container, and it's quite nice. You don't have to think about these instances that much. Things just work. But then, so that's App Engine, and then now here the lessons we learn in this containerization phase is that, first of all, you want to refactor for clear benefits. And what I mean by that is that, as I mentioned, our application ran for 2 years and we didn't touch the code. And the reason is because we didn't have to, right? There was no big benefit for us to change the code. The big benefit happened when ASP.NET Core came along, and then we realized that by porting our application to ASP.NET Core, we can actually run it cheaper. So that was the main motivation for us. So refactoring is great, and we should all do it from time to time. But when you refactor, you should have clear benefits. You're refactoring because of cost. You're refactoring because you want to make it more testable. You want to refactor because you want to make the code more maintainable. You have to define these, and you have to define these metrics, and then spend the time to refactor. Don't just go there and just refactor the code because it feels nice to do so, right? Secondly, the reason why we were able to port from ASP.NET to ASP.NET Core was because we had really good functional tests. I don't mean unit tests. I mean, unit tests are good as well, but we had end-to-end functional tests, meaning we could basically run our functional tests, and then they will go out and grab the feeds, they will convert them, they will serve them, and then something will ping these these endpoints and then check the results and make sure that they are what we expect them to be. Because we had these end-to-end functional tests, when we did the refactoring, we could rely on them to make sure that our things are still working the way they're supposed to be working. Unit tests are nice, but they will never give you that certainty that you need. It's only with functional tests that you get this kind of certainty. So that's why it's very important to have really good functional tests right at the beginning or your app, and keep adding to them as you add functionality, because you want to rely on them as you change things as you go along. And the project organization really matters. Even though our services were all bundled together, they were nicely organized. And because they were nicely organized, we could kind of work through them as we made changes. So make sure you pay attention to project organization, make sure things are nicely organized in a way that makes sense to the team, because this matters in the long term. And there's no magic bullet, meaning, we moved to App Engine Flex to get rid of Windows, and we did, and we made things cheaper. But at the same time, we got other problems with App Engine Flex, with slow deployments and other things, right? So there's no magic solution. It's all about compromises. So make sure you know what those compromises are so you can make an informed decision. All right. So now we got our application running on App Engine, on Linux, which is great. But then around mid-2019, so in beginning of 2019, we moved to App Engine. So in about like 3 or 4 months, there was this new product called Cloud Run from Google Cloud. And what Cloud Run promised is basically, it promised to run containers in a serverless way. Normally when you use serverless things like Lambda or Cloud Functions or Azure Functions, it's usually a function that you define, and that function is kind of limited in what it can do. And we couldn't actually use Cloud Functions for our application because Cloud Functions, even today, it doesn't support C#. But then Cloud Run came along and it basically said, okay, give me any container and I'll run that container in a serverless way, meaning you will have auto-scaling, you will have all the benefits of serverless that you expect from a serverless function, but for a container. So we were quite excited about this. And we said, okay, why don't we try our application, see if we can run it on Cloud Run. And Cloud Run, just to let you know, it's really good for public endpoints like API endpoints or mobile backends. And our application was also a public endpoint, so we were thinking of using Cloud Run there. But it's also good for private endpoints as well. So if you want to have an internal service and some other service within your cluster wants to call an internal service, you can do that with Cloud Run. And the best thing about Cloud Run is the billing time, right? In Cloud Run, you only get charged for the request time. So if no one uses your application, you don't really pay anything because there's no requests. But then if you have 2 requests coming in like this, request 1 and request 2, you only pay from the beginning of request 1 to the end of request 2. And then your container instance might be running longer, but you don't pay for that. You only pay for the request time in 100 millisecond increments. So this was very good for us because our application, it wasn't used all the time. So there was a lot of downtime as well for our application. We could see this saving us a lot of money because when the application is not used, it will scale down to 0 and we won't pay anything. So with that, we said, okay, why don't we move from the VM-based pricing of App Engine to the serverless pricing of Cloud Run. And we tried this in mid-2019, so kind of like May or June. And one thing that you'll realize is that we are getting faster and faster in our iterations, right? Initially, we had like 1 year or 2 year iterations, but now that things are getting containerized and running on Linux and getting smaller and not having to depend on Windows, we are getting faster and faster. So in this case, what we did is that we took our container. First, we updated our ASP.NET Core version from 2.2 to the latest at the time, 3.0, and we deployed to Cloud Run. And that was really easy. It was literally a single command to deploy our container to Cloud Run. And actually, let me show you that. Let me show you how to do this. On GitHub, I have this tutorial called Cloud Run tutorial. I will have the link at the end of this talk. And here I show you how to do a bunch of different scenarios on Cloud Run. But one of them is called public service. So how do you deploy a container as a public service? And I just want to show you this quickly. First, you need to build your container. And for that, you can use Google Cloud Build to build your container in the cloud and then save that into Google Cloud Container Registry. So this command does that, and I already did that before the talk. And then to deploy to Cloud Run, all you need to do is just say gcloud run deploy, give your service a name, in this case hello world public, point to your image that you just built here, and then just say I want to deploy the managed version of Cloud Run, and I want it to be public, right? So let's actually do this. So I'm here in my terminal, and then let's say, let me make sure my service name is set. So it is set. And now this is creating a revision, routing traffic to that revision, and setting the IAM policy. So within a few seconds, I would be deploying my container in Cloud Run, right? So compared to App Engine Flex, this is much faster, and you just basically wait a few seconds for things to work. And then if you go back to Google Cloud, in Cloud Run, you can see I have a bunch of services. I'm under Cloud Run area. I have a bunch of services. One of them is Hello World Public that we just deployed. You can see that I get a nice dashboard by default. If I look at revisions, you see that I deployed multiple revisions, but this one was just deployed now. That's getting 100% of the traffic. I can change traffic rules between different revisions, so that same notion comes from App Engine to Cloud Run. I can look at the logs right from here and see what my application is doing. And then I also get a URL for my application by default. And if I click on that URL, it will just say hello world, hello v1. So you can see that things are really easy with Cloud Run. So for us, basically, we just built our container and then just deploy it. And then we had our app running in Cloud Run. So it was really easy. Now, the pros and cons for this is that we got rid of VMs finally. And then we got introduced into serverless billing. So this really reduced the cost for us, right? Instead of paying for the VMs for the whole time, now we were only paying for when people use our application. And this basically made our application free. So our whole goal was achieved by Cloud Run. It became free because Cloud Run has a free tier, and that free tier was enough for our application. We had quick deployments, as you saw. It was like seconds of deployments instead of waiting for minutes. The developer experience on Cloud Run is great. So you have integrated logging, revision and traffic management, and many other things. And finally, we also like the fact that Cloud Run is based on a project called Knative. Knative, it's an open source project, and you can install it on any Kubernetes cluster, and you can get the serverless capabilities for containers on a Kubernetes cluster. And Cloud Run is based on that. And what that means for us is that, right now we are running in Google Cloud, but if I want to take my app and move to some other Kubernetes cluster on-prem or some other cloud provider, I can do that easily. So I'm not really locked into Google Cloud. So it was really good for us as well. And the last thing is that we were still running as a monolith. It was still a single service with everything bundled together. So we had the monolith issues still. And these issues are, number one, scaling. We could only scale everything all at once. So if you want to scale the web API, we had to scale reader and the converter as well. If we had to scale reader, we had to scale the web API as well. Everything has to scale all at once or nothing at all, right? We had an issue with cold starts. So, in Cloud Run, if your container is not running, it scales down to 0, which means that our reader, the thing that goes and reads the feeds, is also down, right? And then when someone comes along and wakes the container up, then reader has to go and get the feeds before we have something, because everything is in memory, right? So the cold starts became a problem for us. Our state is already in memory. It's still in memory. So, again, if someone comes along and we don't have the latest feeds, we have to go and get it. So there's no persistence where we can go and grab the feeds from. So that was becoming a problem as well. And again, there was no way to update individual services. So if I want to update the converter, there was no way to do that. Because usually in our application, the reader is just a reader. It just goes and reads the RSS feeds. So you don't need to change that. The web API doesn't change either because it's a common API that we defined and we haven't really changed it. But the converter, the thing that reads the feeds and then converts into a common format, that changes a lot because the news feeds, they change their format quite a lot. And then as they change it, we need to update the rules in the converter, right? So ideally, we don't touch the reader and the web API, but we update the converter quite a lot. But we can't do that in this monolith case because everything is bundled together. So at some point, we had to fix this monolith issues, and that was the next phase of our application. So we had to take the monolith and break it down into smaller pieces, but then there's all these questions like, first of all, how do you break your monolith? What are the good ways of breaking the monolith? There's no right answer, by the way. I mean, different people say different things, but there's really no good answer on how do you take a monolith and break it down. You have to really define the boundaries of your services, and you have to make things really separate and then start breaking it down. But we have to really think about this in a deep way and make sure that we understand where our services are and make sure that we can cleanly break things down. And then once you break your monolith into multiple services, then you need to worry about communication, right? Because before, if one service wants to call another service, they just make a method call, right? A function call or whatever you want to call it, because everything is in the same place. But then once you have two separate services, then how do they call each other? Do they call each other through HTTP or do they communicate with messages? Do you use regular HTTP or do you use gRPC? So you have to think about these things because things become more complicated. And also you need to think about persistence, right? So we wanted to go from in-memory persistence to something more persistent. But then one problem that you can run into is that you can break your services into multiple microservices, but then behind the scenes, they're using the same backend, right? They're using a single backend. Well, if you have that, then that kind of defeats the purpose of your microservices because your microservices, they still have a dependency. Now, the dependency is not in the code, but it's in the backend. So you need to find a way to also break the persistence layer as well and think about that as well. So as you can see, it's not that easy to break a service, even a simple service, into multiple microservices. You need to think about these questions. So now, in early 2020, so the beginning of this year, I finally took upon to break the monolith into microservices. And this is what we ended up with. So first, we realized that we have three services: the reader, who reads the feeds, the transformer, who transforms them into a common format, and the web API. So we had to have these three separate services. First, we created the reader cloud run service. And this reader service is a private service. It doesn't have to be called publicly because all it does is that it goes through a list of sources and grabs the RSS feeds, right? But who calls this reader? I mean, who triggers this reader? In Google Cloud, there's something called Cloud Scheduler. It's like a cron job, but in the cloud. So you can say, I want to call this endpoint every hour, and then Cloud Scheduler can basically make a call to reader every hour, and then reader, once it receives that request, it will go and fetch the RSS feeds, and then it will save them. Now, where it saves is cloud storage. Cloud storage, it's an object storage in Google Cloud, and you can basically create a bucket, and in this bucket, you can save any kind of files. So what Cloud Reader does is that it gets the RSS feeds and just saves them into a bucket as JSON. So it just does that. And this is very simple. This is very clean. Reader, all it cares is that, okay, these are the feeds that I need to read, and these are the ones, and then this is where I need to save. That's all it needs to know about. Now, once these are saved, the JSON files are saved here, what you can do is that you can set Google Cloud Storage to trigger events when something happens. So when something is saved here, Cloud Storage can send a notification to a topic in Google Cloud pops up, which is a messaging system in Google Cloud. And then you can have that pops up topic call another Cloud Run service, right? So the way it works is that the reader saves the file into the bucket, that triggers a notification to the pops up, and then pops up says, okay, I got this new message, let me pass that to this Cloud Run service. So this converter, all it does is that it will receive a notification that a JSON file is saved. It will go and read the JSON, and it will use the rules that we defined to save into a common format. So to do that, it will basically do the conversion, and then it will save into Cloud Firestore. Cloud Firestore is a NoSQL database, and it's perfect for saving JSON-like data. So that's why we used it. Now in this model, again, it's very simple. Converter, all it looks for is that this notification that it receives, and once it receives the notification, it knows where to read these JSON files, and then it just saves to the Firestore, and that's it. And then we also have a web API. This is the third service, and this web API, it just talks to Firestore. It basically just gets the information from Firestore, and the clients, they will talk to the web API. So this is the final architecture we have. As you can see, it's more complicated than what we used to have, but at the same time, it's much more resilient. Things are much more loosely coupled. So reader doesn't know anything about converter or web. The web doesn't know anything other than Firestore. If you want to scale the web, we can scale it individually. If you want to scale reader to 1 or n, we can do that. The converter that we need to update quite often can be updated individually, and all the rules that we have here can be updated quite easily without having to touch reader and web, right? So this is definitely much better architecture than what we used to have. So the pros and cons in this case is that loosely coupled architecture is always good. Being able to update individual services, that's what we wanted. Being able to use different languages. I mean, we are still using C# in all of the services, but at this stage, these services can be any language, right? So we not only release ourselves from Windows, but we can actually also use other languages than C# if we want to. And if we introduce another service, we can deploy that maybe a Java service in the system, and it will be fine. And we are definitely using better utilization of sources, so we don't have these VMs that are just laying around. We have Cloud Run services that scale up and down as they need, but if no one uses them, they scale down. So we are running much more efficiently. And finally, we introduce persistence after all these years. Now we have Cloud Firestore that comes into play. So if a user comes along and the container is scaled down, it will wake up and immediately get it from Firestore. That's really quick, and there's no cold start issue anymore, really. And of course, the flip side is that there's lots of moving parts now. So it's not a single service that you deploy. It's multiple services. And then the deployment is more complex, but that's expected. And it's probably more expensive than deploying the monolith. I don't know. I didn't do the calculation, so I didn't look at the numbers. But instead of having a single service, we have multiple services. We have cloud storage. We have PubSub. We have Firestore. So when you add them up, they probably end up being more expensive, but that's the price that you need to pay to get this kind of resilience. All right, so I think that kind of concludes my talk. I just want to point out, I couldn't go through the code with you because I'm already out of time, but I just want to point out that, in Cloud Run, I have these converter, reader, and web deployed. And then on GitHub, if you go to, I will share this link at the end. If you go here, I explain this architecture, and I have scripts. Hello, everyone. To take advantage of it, and that will involve some kind of, you can have huge benefits if you know what you're doing, right? So look into that. Sometimes it's not just code changes that you need to do, right? Sometimes it's just changing the environment. If you're moving to the right kind of environment, can have huge benefits. Sometimes you're gonna be doing non-optimal solutions. For example, when we moved to App Engine Flex, it wasn't really optimal because it was VM based and it was slow deployments, but it was a good stepping stone to Cloud Run, right? So going through that transformation was still good. So when you do these non-optimal solutions, time is still spent well if it's for something better that's coming along later. Yeah, I mean, if you want to move to the cloud, you need to kind of architect for the cloud. So as you can see, our single monolith, we could have kept it like that in the cloud, but it wouldn't be optimal, right? And we had to kind of break it down into multiple services and take advantage of what cloud provides with cloud storage and PubSub and Firestore. So we had to rewrite our application to take advantage of that. And you should be ready for that. I mean, no matter what environment you're running into, learn the environment as much as you can and try to take advantage of it. And that will involve some kind of rewrite at some point. And monolith decomposition is really, really hard. Even for a simple application like this, it wasn't easy to refactor the code, figure out how to break it down, figure out what processes to use, things like that. So you really need a good reason for it. So before you go ahead and say, let's break this down because it feels nice, you need to find a really good reason for it, and you need to kind of be able to say, we are breaking this down because of this, and we will get this benefit. You should be able to say that and then get into breaking it down, because it's going to be a lot of work, no matter how simple your application might be. All right, I'm already out of time. So thanks for listening. Hopefully this was useful to you. So this is my Twitter. And if you want to read more about this, I have a blog series on this link. If you want to look at the code, it's on GitHub under Amathus. And then if you want to learn more about Cloud Run, I have a tutorial on GitHub, and this is the main link for Cloud Run. Again, I'm sorry that I wasn't there, but hopefully in a future edition, I will be there, and I will be around for any questions as well. So feel free to reach out to me if you have any questions. Thanks very much for listening.
Hi, Mete. Thank you for joining us. Thanks for your great talk. I'm very glad to see you here.
Thanks for having me. It was a lot of fun.
So how are you doing during the lockdown?
Oh, that's a good question. Well, I'm trying to see it in a positive light. I'm trying to see how I can make a good use of this time. So usually I travel a lot, especially at this time of the year, like in March and April, because there's also conferences. Now I don't travel, I'm mostly at home. So I'm trying to do things that I wouldn't normally be able to do, like learning new things or reading things that I wanted to read. So in that sense, it's been pretty good. But yeah, I mean, there are days where you really want to get out, but you can't, and we have to deal with that.
Yeah, we can understand you. Quite the same here. Everything is locked, everything is closed, and we need to be safe and to take care of each other, staying at home.
Yeah.
So there is a question coming from our participant. Do you have any recommendations how to eliminate supporting multiple architectures simultaneously while you are moving to the new infrastructure?
Yeah, that's a tough one. And I think there isn't a good answer, to be honest, because, like, for example, in our case, we were trying to move from .NET Framework on Windows to .NET Core on Linux. I mean, we did it in a one-shot kind of thing, like in the sense that we rewrote everything and then we kind of tested it out like gradually. And then one day we just said, okay, let's just switch. And we did it that way. But in that transition period, like we had to maintain both systems. And if there was a bug in one system on Windows, we had to port that to the Linux one, keeping the time frame to minimal. Like, so, the time where you had to do this maintenance of both architectures minimal is the key. But I don't think there's a magic bullet where you can just say, okay, like I don't have to maintain this now right away. It has to be maintained at some point, simultaneously, unfortunately, until you can do the switch. But what people usually do is that they usually like use things like traffic splitting and deploy the new version along with the old version of the application and start kind of gradually ramping traffic to the new version. And then once all 100% of the traffic goes to the new version, they kind of kill off the old one. So that's one way of like ramping up to the new version. But again, like during that time, as you're ramping up, you unfortunately have to maintain it. I don't think there's like a magic solution there.
Okay, thank you for your answer. I don't see any new questions. Maybe people need more time to type them because, you know, English is not our primary language. So maybe there are some difficulties to set the question. But if you could join us on Telegram and speak to people afterward if they have questions, that would be great.
Yeah, I'll definitely check Telegram. And people can also reach out to me. I think I share my information at the end of the talk. So if anyone has any questions, they can reach out to me on Twitter or email or whatever.
Great. Thank you for sharing your contacts, and thank you for being with us online. And it was a great pleasure to hear your talk here.
Yeah, thanks a lot for having me, and stay safe. And hopefully I'll see you at some point in a real conference in Kiev.
We hope
take
to.
Care.
Take care too. Bye-bye.
See you.